All right, here we are in Chapter 1 on Ingredients of Change, Functions and Limits. This is Section 1.6 on Models in Finance. So financial models that deal with the value of money over time are usually exponential functions or are constructed from exponential functions. Now we've got a couple of things. We've got capitalization, and now that's the process of evaluating the future value of money, the money's worth, a given sum today at some point in the future. So we have some amount today, and we want to know what the value is going to be in the future. Now, the other process in reverse is evaluating the present value of money with the stated future value. And that's called discounting. So an amount of money received today is actually going to be worth more than the same amount received at some time in the future. And this is because it leads us to the concept of future value and present value. And that's all including interest and how we get those future values. All right. So the present value and future value, the value today at time equals 0 of an investment or loan is called the present value. The present value is denoted as P, and the present value of an investment is referred to usually as principal, and the present value of a loan is referred to as the face value. And a lot of times what we'll do in this class is P for principal, and we don't talk about as much about loans, but we will. Now, the future value of investment or loan at a specific time, T, is the sum of the present value plus all interest accumulated during the specified time. Now, the future value at time T is denoted as F of T, and we'll have a different sub values for the F. We'll have, simple interest, compound interest, and so on. And F of 0, basically at time 0, that's just going to be equal to the principal. So when we first put the money into an investment or borrow a loan, that principal we borrow or put in, that's how much the future value is at time 0. Now, as a lender, they expect to be compensated for loaning money, and borrowers expect to pay to borrow the money. Now, the amount a borrower expects to pay above the face value and the amount a lender expects to be compensated is called the interest. So, if you're putting your money into the bank, you're lending your money to the bank, and they can actually invest it, and so they're going to pay you so much interest. Or if you go to the bank and want to buy a house and borrow money, they're going to expect to get interest back for letting you borrow that money. Now, simple interest, that's the simplest form of loans or investments where the interest is earned on the face value only, okay? And we have a couple things here to look at. Now we have a nominal rate of interest. Now an interest rate is reported as an annual interest rate in decimal form or annual percentage rate if it's in a percentage form. So, the annual interest rate might be 0.05 or 0.02. And the annual percentage rate is interest form, it might be 2.4%. Okay, so that's going to be kind of the difference there. One's going to be decimal, one's going to be percent. It refers to the increase that is earned on the principal only. Now, this annual interest rate is referred to as the nominal rate in decimal form or the APR, the annual percentage rate in the percentage form. So let's look at simple interest. So the accumulated interest I after T years at an annual interest rate R on a present value of P dollars is calculated as I of T equals P times R times T dollars. Okay, so that's our principal. That's our rate in decimal form, and T is the time based on whatever our rate's in. So if it's in, percent as in whatever, then we're going to usually use T for uh, um, years. By adding the interest to the present value, P, we can obtain the future value at any time. And so this is the subscript I was talking about. So F for simple interest of T equals P plus PRT, okay? Now, usually what we do is we simplify and say, well, let's pull out that P, and then it's just times 1 plus RT. So if we pulled out that P, we'll have a 1 left here and RT left here. And that's how we're going to do that calculation. We'll just take whatever our principal is times 1 plus our interest rate in decimal form times the time, and then that will give us our future value in dollars. So this is a good example. And so our task is calculate the total amount due after 4 years on a loan of $3,500 with 4% simple interest. All right, so we're going to look at the future value at time t for simple interest. And remember, that's P times 1 plus RT, okay? So now we plug in everything we know. Well, this is 4 years, so that's our T. We loan, that was 3,500, that's our P. And 4%, that's our R, but remember we have to convert it to a decimal form to put it into our equation. And so we've got basically everything we need. We have P, we have R, and we have T. So F of S of T is 4 is equal to our principal, 3,500, times 1 plus R, which was 0.04, times T, which was 4. And now we just plug all that into our calculator. And so we'll have, let's see if I'll do this, write all this down so we can go over to the calculator so we know we're doing it right. We had 3,500 times 1 plus our rate, which was 4%, times the number of years was 4, in parentheses, and 4060 is going to be how much that future value is going to be. So this is equal to 4060. That's the amount due after 4 years on a loan of $3,500 at 4% simple interest. And so that's the value we're looking for here, okay? And again, we just plugged everything we were given. This is part of the formula. And then we just had to plug in the R and the T, and we get our value in the future. All right, so I'll stop there and I'll come back with more.